For this one, what's the first thing I have to do? Not forget to take out the -1, and I get x minus 1. Remember I told you that everyone has to remember to get a 1 in front of their x, and when it's a number, everyone remembers to pull it out, but when it's actually just -1, you forget to take it out. That's where we're at. So this one, both of them, this one has a +0 at the back. And remember that radical graphs, if it's just a transformed radical graph, normally starts at 0, 0. The only thing that can move it are vertical and horizontal translations. And the only thing that can make it less than or equal to is reflections. Well, there are 2 reflections. So I know that my domain is going to be x is less than or equal to because of this one. And it's a 1 because it's 1 to the right. And my range is going to be y is less than or equal to because of that -0, which is p. All right. A student is analyzing the graph of the function y equals g of x. She correctly deduces that the range of the function of y equals g of x is this. That's the range of the function of the square rooted function, correct? When you square root anything, when you square root a function, what goes away? It's right here. I'll put it on there. When you square root a function, what goes away?
The negative x's.
The negative y's. The negative y's go away. And what do we do with all of our y's other than that? They get rooted, right? Square rooted. So if I want to go back to what they were, what would I do? Square them. So this one here says the point 1, 2 lies on the graph of y equals g of x. So she makes 4 statements about the graph of y equals g of x. The point 1, 2 lies on the graph of y equals g of x. The graph of y equals g of x has no x-intercepts. Is that true? X-intercepts would stay the same, correct? And it's from 0 to 4, so that's false. That is what we need, though. It must be false. I'm going to go, looks like it's true. False. Statement 3, the graph of y equals g of x has no points in quadrants 3 or 4. 1, 2, 3, 4. The graph of g of x has no points in 3 or 4. Is that true? This is the range of y equals g of x, right? Is there guarantee that there was no points down here for the original? That's g of x, not root g of x. That's g of x. This is g of x. G of x has no points in quadrants 3 and 4. Is that guaranteed to be true when I give you the range of only the radical, the square rooted one? No, the square rooted one could be between 0 and 4. It could be like this, let's say. This would be 4. This would be 0. Does that mean that there was none of this before? Do we even have remnants of that when we have the range of the root function? No. So could there have been points down here? There absolutely could have. So the graph has no points. That's false. And the maximum of the graph is 2. The maximum of the graph of g of x, which is the original, was not 2. What was it? 16. Some other combination. That's so dumb. It must be false. Trust me, on a diploma, they ain't putting that. All right. Which statement must be true? Which one must be true? One only. Because if you're from 0 to 4, 1, 2 lies on the graph. I guess must be true. None. Could be true. Not must be true. I read it wrong. Right. So none of them must be true. 1, 2 could be true, but we don't have actually any coordinates, so we can't say it must be true. And luckily, I don't think they use must on the diploma either. These are just
a terrible question.
It's just more of a reading comp at that point. Okay. So, what do we have to do when we are given a rational tomorrow? What do we have to do immediately?
Yo, like split them up, make them into their like x.
Factor it.
Factor, yeah, that's the word.
There we go. So we get x minus 7, x minus 7, x minus 2. What happens when I have two factors that cancel? That means I have a what?
Point discontinuity.
And it's at 7 and what? When this cancels off, what am I left with in my numerator?
1.
1. I'm going to find f of 7, and I get 1 over 7 minus 2, so it's 1 over 5. So I have 7 and 1/5. I'm writing everything before I answer any of these questions. What's my vertical asymptote?
x equals 2.
X equals 2. What's my horizontal asymptote?
There isn't one.
There is always a horizontal to invert. Y equals what?
0.
0, because what's left over is transformed form. 1 over x plus minus 2 plus 0, is it not? It means it's been moved nowhere. So it's y equals 0. Also, there's the rule that if the numerator is a smaller degree than the denominator, which it is, this is degree 0, this is degree 1 now, it's y equals 0 every single time. So when your numerator is a smaller degree, it's actually in transformed form, and you get y equals 0. So let's answer some questions. Which of the following statements is true? The horizontal asymptote has an equation of y equals 0. A. Which of the following statements is true regarding the graph of f of x? The vertical asymptote is at x equals 2. And if the point of discontinuity of the graph can be the response AB, 7 1/5, then the value of 7 1/5 is in the nearest tenth. So what's 7 plus 1/5? 7.2.
2.
Okay, the range of the graph. Once again, we're given the range of a square-rooted graph, right? Are we not? It's between 3 and 12. Which of the following points could lie? So here's the could lie thing because they didn't give us actually what the y's are. So which one could lie? So we have between 3 and 12. What were they? They're now 3 and 12. What were they? This is not 6. 9 and 144. And that's on the graph of f of x, right? Because this is on the graph of root f of x. Yes? So how do I get root f of x? I take the square root of my y's and keep my x's. Remember? X root y. So which graph could fall? D is the only one. Okay, we have considered the function. First thing I'm going to do is rewrite it. So I get negative 4 root 5 x minus 3/5 plus 2. Please keep remembering that you need to have a 1 in front of your x. So, the range of this function. Now remember, that is the square root function. It's normally 0, 0. The only way it can move is if it actually is horizontally or vertically translated. It's vertically translated to up, and there is a reflection. Right? These affect my y's. Remember I told you that we draw that. This affects my y, so that affects my range. And then this affects my x. You want to make a big y? Affects my y. That affects my x. So my range is what they're talking about. I'm going to flip my inequality, so it's going to be y is less than or equal to 2, which is C. Then this one says the domain of the function. So what affects my x? This in here, with radicals, it's only the horizontal translation. So it's going to be 3/5, positive 3/5. And its x is greater than or equal to because it's a positive 5. There's no reflection. So what is 3 divided by 5? It's the nearest 10. Your decimal? Okay, I'm giving you 5 minutes again. Next 2 pages. Number 10 is based off of this question because it says use this for next 3 questions. This one wants g of x is root x. What's the domain? So if I go back to this graph here and I say g of x equals root x, which would it be? A, B, C, or D? So if we look at this one, when you type that one in, what do you get? Well, we get x is greater than or equal to 0.6, right? That's what we said?
Yep.
X was greater than or equal to 0.6. And when I take the square root of that, what happens? Yeah, the y, what is the y at 0.6?
Oh, 2.
It was 2. So this started at 0.6 and 2, correct? So if we look at the graph, I'm using the wrong, this wrong computer doesn't have a graph on it. Put the graph into your calculator, this one. Type that one in.
You do have to.
Batteries.
Yeah.
So you have a graph that looks like something like this. If this is a sketch on your diploma or on the unit test, you're getting no marks. This is on multiple choice. I'm allowed to do this. I repeat myself. She's like, this left and multiple choice. You do it like that. Meaning, take my calculator. Then you did this. How dare you? How dare you? Okay. So what happens is that. Come on. Okay, sure. Say whatever. Okay, cool. When I take the square root of this function, that's going bye-bye, right? This one here is at what? 0.6. How do I find this one? Second trace value, apply. I go to second trace 0, number 2. Left bound.
Just look at the options in the multiple choice, you win.
I know, but I'm just wanting to do it. Right bound, enter, enter. And I get 0.65. So it's going to be this one. Because when you square root a function, the negatives go away, right? We know that.
Yes.
All right. Now this one. This one you have to read. People don't read thoroughly. You have to look and see what the variables stand for. So this one says A is positive, so I go and do this. This one says B is negative. So I go and put the negative here. But you guys don't read that, so then you get it wrong. It's crazy how that works. So this one here, our X is going to be less than or equal to H because of the reflection, and our Y is going to be greater than or equal to K because no reflection, which is D. Okay, f of x is a linear function. This is not obviously f of x because that is not linear, right? fx is a linear function. The graphing calculator screenshot of the graph of y equals root f of x is shown. The points 0.5 and 0 and 5, 3 lie on the graph. On the graph that doesn't actually show it. Cool. There we are. On the graph of root f of x, y. And you have to watch yourself on these root ones. It'll look like the graph isn't there, and then you press a value and it's actually there. Like that previous one, it doesn't show 2 on there. It looks like it's shorter, but 2 is actually a point on the graph. So you have to watch it. Your calculator draws radical graphs, a little sketchy. Okay, so I want f of 5. Well, this is root, right? So if I go to 1, 2, 3, 4, 5, I follow it up. People are like, I'm not sure what it is. Oh, I'm sure what it is. It's right there. 5, 3, right? So 5, 3 is on the square root. And remember, xy becomes x root y when we square root. So this 5, 3, what was it? 5, 9. We're working backwards. Boom. What about negative 5? Unable to determine from the given information. Nope.
You have 2 points, and you know that they're on the linear line. You use those 2 points.
Yeah, but not from this graph.
No, but Mrs. Lepp,
You have 2 points.
if you know 2 points, you can find this. You know 5, 9. You know 5, 9 and 0.50. So you can find the slope from that, and then you can work
Find your
backwards.
B value, and you can make it go up.
Also can find the y.
Oh, I know what you're
Find
saying.
the slope, and then you go down from each point, and then negative
Oh,
5.
you definitely don't need to do that.
But I did it anyways.
No. I mean like how he did. He did a table of values and worked his way down by sloping every point. You didn't need to do that.
You're making it sound like it was like an hour of work. It was just like 30 seconds.
You can't.
I made
Okay.
extra shirts.
You could. They won't make you find a linear equation. Now, the reason why they won't make you find a linear equation is linear is grade 10. So that's nice of them. But if they didn't give you specific points, so this one's going to what? Stay the same. This one's going to be 5, 9, right? So 0.5 and 0, and 5 and 9. And so what they did is they found the slope y2 minus y1 over x2 minus x1. You use 1 point and you can solve for b, and then you could just plug in the point and find it. Or you could work your way through. Either way, it would get you to 11. Negative 11. But we won't have to find linears, which is nice. Okay, the graph of this is shown the domain of root f of x. Well, I know this is staying, 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 I know 0.5 is going, 0.7, 0.7. Rain down from 4 to 2. Rain down from 4 to 2. Boom. Boom. And you can't just draw your arrow like 80 feet to the left when you don't have any more things. You have to go a little past with an arrow, right? You can't just be like, I feel like I'm just gonna put my feelings into this and just extend for that. You can't do that. Okay? So this one is between negative infinity and negative 2 and 3 and infinity. Is it included or non-inclusive? Inclusive because it can equal 0. On the graph above, sketch graph done. Cool. Given the function y equals f of x shown in the graph to the right, how many invariant points are there? Where do invariant points happen when I take the square root of a graph?
0.
Zeros and ones. How many are there?
2.
2. So if this is asked tomorrow, I could give you 77 different graphs. And if I ask you where the invariant points are, you see how many cross through 0 and how many cross through 1. You just tell me how many there are. That's it. That's all there is. Okay, this one is fog. So f of g of x, don't fill in the dot and tell me it's multiplication. Okay, so we have f of x squared. Okay, so we're going to get square root. This is going to go in for the x's and f, right? So we're going to get square root x squared minus 1. Yeah? When you type that one into your calculator, you're going to see that it does what? What does it do? Is it between them or outside of them? Outside of them. Because technically you have a graph like this. This is a 1. And we're taking the square root of that graph, aren't we? So this and this is staying this, and this is staying, this is going here, this is going here, this is dropping down, this is dropping down. And we end up with a graph like this, don't we, when you type it in? Because what was the original graph? X squared minus 1. And what did I do to it? I square rooted it. So whenever you have a concave up parabola and you square root it, you get the outside arms, right? When you have a concave down parabola, you get the domain between them, between the values, because it'll keep this way. So it's going to be C. Okay, this one, we have g of f of negative 2. So we have to go g of f of negative 2. Why is this thing spinning?
I have a question.
So, yo.
On the last one, isn't the restriction from the graph f of x have to stay around? Because it has to.
No.
No?
That happens when you input. So this is the graph. If I had done it the other way, if it was g of f of x, then I would get root x minus 1 and square that. That would have to stay. So it's once you fill it in, once you fill in properly, if there's still a radical sitting there, then you have to state the restriction. So the other way around, yes, I would have had to say x is greater than or equal to 1, even though I would have got x minus 1 as my line. So this one, they gave me f of negative 2, so I have g of negative 4, and now I just need to find out what that is, running equal signs down the left-hand side, so I get 2 of negative 4 squared minus 1. So I get 2 times 16 minus 1, which is? Okay, this one. Given the function f of x equals x squared minus 4, so I get y equals x minus 2 over x squared minus 4. Which of the following statements are true? So this one, we get x minus 2 is the difference of squares, x minus 2x plus 2. Remember when your entire numerator cancels off, what are you left with?
1.
A 1. And this is just transformed form left, correct? This is technically 1 over x plus 2 plus 0. That's transformed form. Yeah. Yeah. So this one has, the function has 1 point discontinuity and 1 vertical asymptote. The function has no point discontinuity. That makes no sense. The function has no point. Doesn't make any sense. The function is 2 vertical. Hey. If factors cancel, you have a point discontinuity. Now, let's go back. How would I find the y? Because that's my standard of excellence. I would go 1 over, what would I do? X plus 2, and then I would fill in a, for what? What would I fill in? 2. So I would get 2 and 1 over 4. Am I allowed to write P of D on my diploma? Or on a test?
Yes.
No, that could mean population of Dudsbury. Didsbury. I don't think there is a Dudsbury. I'm sure there's one. Didsbury. Dudsbury. Detroit is where you all went to. Why'd you all go there? Didsbury is a great place to be. I called it Dudsbury first.
Is not a good place to be.
Great place to be. All right, here we are. Beautiful this time of year. The function y equals g of x over f of x is shown below, and the vertical asymptote is at x equals 2, and horizontal asymptote at y equals 1. Shh. Which of the following could be true? So, I know I can write these out. Y equals g of x over f of x, so I could do this one. Y equals g of x over f of x. Bless you. Wait. B would be y equals g of x over f of x. C, y equals g of x over f of x. And D would be y equals g of x over f of x. All right. So this one has a vertical asymptote where? X equals -2. So that's wrong, I need 2. This one is x equals -2. Goodbye. This one is x equals 2. This one's x equals 2. So I'm in some order of this statement here. And then this other one here, my y is at 1. What is this one's y equals? Y equals 0. And the numerator is smaller than the denominator is 0, but also this is in transformed form. I have a +0 at the back, don't I? Yeah. So nope. I don't know why I circled it there. It would be. Which of the following is true about this rational? These cancel off. What do I do then? Plug the 2 back in. So I get 2 times 2 minus b, which is 4 minus 2b. So my coordinate is at 2 and 4 minus 2b.
Wait, sorry, why is 1C again?
Because the asymptote is at y equals 1.
Yeah.
And that one is at y equals 0, and that one is at x plus a. So a just would have to be -1.
Okay.
That's why it says which could be true. It's not saying is true. Yeah. It's also a way that you can't just punch into your calculator. So this one has the rational function 2x minus 1 over x minus 2 is transformation of the function of y equals 1 over x. Cross that one. So is this one. Yeah.
Around the x-axis?
You could possibly get this one. You would have to go y equals 1 over before stretched by a factor. It's not even written right. Vertically, wait a minute, whatever. Stretched about the x-axis by a factor of 4. So you could have a 4, and you'd have x plus 2, and then plus 3, and then you have to make a common denominator to make it into that form. Multiply by 1, or put it over 1, multiply by x plus 2, multiply by x plus 2, and you'd get y equals 4 over x plus 2 plus 3x plus 6 over x plus 2. And then we would get y equals 3x plus 10. That's you. Over x plus 2. So your value of a is 3, 10, 2. That one would, this one, no. They're not going to make you transform it. Okay. So this one has 2x, 3x minus 1 over x squared. They want the y, so they want the horizontal asymptote and the vertical asymptote. What is x squared just the same as writing? X times x, right? So I could technically get y equals 2 times x times 3x minus 1 over x times x. And these would cancel. And then you get a pointed discontinuity at 0 and whatever. But ignore that. I wanted you guys to have this one to know that x squared is just x times x and they could cancel. That's all I really wanted you to do. They won't give you anything that's of this, because you're technically having an x cancel off with an x, and then an x is left behind, so then is that a vertical and a point discontinuity? They're not going to do that to you. Right? Because your x left behind would be 0 as well. So this is outside the scope of ours. This is into calculus. This one, a rational function is given by f of x equals that. So what am I going to have to do? Factor it, correct? So I get negative 2x squared plus 5x minus 3. I get negative 2x squared plus 6x, plus 2 and 3. Sorry. Let's multiply, give me 6, and add, give me 5. 2x plus 3x minus 3. Take out a negative 2x, I'm left with x minus 1. Take out a 3, I'm left with x minus 1. Negative 2x plus 3, x minus 1. So, don't factor it wrong and use 6 and 1. That's not true. So we're going to get negative 2x plus 3, x minus 1, over x minus 1. They cancel. And what am I actually left with? What kind of function am I left with? A linear function. So a line with an open dot. That's it. Right? I'm left with a line with an open dot. The line is negative 2x plus 3, and it has an open dot at 1 and something. How do I find that something? Well, I plug the 1 in. So I get negative 2 times 1 plus 3, which is what? So it's at 1. What's the equation of the horizontal asymptote for this one? Horizontal lines are what equals lines? And vertical lines are what equals lines? Vertical lines are what equals lines? X. And horizontal are what equals lines? Y. I've already just counted out 2 of them. So the catch here is that horizontal asymptotes, the horizontal axis, so the x-axis is actually y equals 0, right? And the vertical axis is actually x equals 0, because all x equals lines are vertical lines and all y equals lines are horizontal lines. So if I want a horizontal asymptote, it better be y equals. I have at least about 50-50 chance at this point. Now, this one is in y equals 2, 15x minus 1. My numerator is smaller than my denominator, so it's 0, right? But also this is in transformed form, is it not? Number over some sort of x plus 0. That's why it's 0. This one, they want h of negative 2. So I have to do h of negative 2 equals f of negative 2 plus g of negative 2. So I go to negative 2, and I have to do f of negative 2, which is 7, plus g of negative 2, which is negative 1. And so I get 6. The graph of y equals f of x is sketched below. Determine the domain and range of y equals root f of x. What do we have to do? 0, 1 stays the same, right? 0.5 goes up to 0.7. Then I can do every point if I want to. This one is at, here is 4. 4 is right here. It's a weird spot, correct? But can I not rain it down and make it go to 2? Rain, 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 2. I can go to 9, make it rain down. Rain, 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 rain. It's going to rain to 3. Can I do more along the way if I want to? Sure. I can go to 7. Square root 7 is going to drop to 2.6. So I go to where 7 is, which is here, and I rain it down. And I get 2.6. So could I do every single one and just rain them down to the root of what that number is? Could I get a whole bunch of points? Now I'm going to stop here. Why did I stop there? Yeah, there's no arrow. It's a closed dot, right? So this one is my domain. Is going to be x such that negative 1 is less than or equal to x is less than or equal to 3. I get a sandwich going on in there. set notation, in interval notation, -1 to 3. My range is y such that I sandwich between 0 and 3. 0 is less than or equal to y is less than or equal to 3. Min to max, always. Yeah. Less than signs. Okay, then we're going to flip over. Okay, this one we have to find f of 3. f of 3. So first off, I do f of 3. F of 3 is what answer? 4. Input x, get out y. It's 4. So now I have f of 4. And what's f of 4? 2. Done. If I'm adding, subtracting, or multiplying functions, where can I only add, subtract, and multiply functions? 2 functions. Where they both
Exist.
where they both exist, the domain of both of them, correct? Now this one is from -4 to 2, and this one is from -4 to 4. So where can I calculate between? -4 to 2 is where I'm going to have some domain, correct? And then we just math. That's it. Literally, we just math. So I'm going to go start at -4. F of -4, that's a lie. Y equals f of -4 minus g of -4. So I get y equals -2. This is f, right? Ooh, I don't even know what I just did. Yeah, first one's f. So y equals -2 minus 3, and so I get -5. So now I'm at -4 and -5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Then I do the next one. Y equals f of -3 minus g of -3. F of -3 is -1. G of -3 is 2. So I get -3. So -3, -3. Then y equals f of -2 minus g of -2. So y equals 0 minus 1, which is -1. So -2, -1. Then I get y equals f of -1 minus g of -1. Now, if this vertex wasn't at -1, guys, I would have to include the vertex, because the vertex is going to do some turning, right? You have to include those critical numbers when we're doing it. So if it had been at like -1.5, I would have to find -1.5 as well. Okay, so then we have f of -1, which is 1, minus g of -1, which is 0, which is 1. So I get -1 and 1. Then 0. Y equals f of 0 minus g of 0. So y equals 2 minus 1, which is 1. Now, guys, this is what I want you to see. I would be jolting across there, correct? So is it better to maybe check the point in between to see if it goes any higher between those, or do I just run across and just hope for the best? No, you want to check. So I'm going to use -0.5. F of -0.5 minus g of -0.5.
Go back in time.
So f of -0.5 is 1.5, and g is 0.5. So it's 1.5 minus 0.5, which is 1. So it does actually go across, but is it better that I checked it to know that I don't actually have a maximum on there? Because sometimes there is.
I would actually do it.
Then we do 1, which would be 3 minus 2, which is 1. And then we do 2, which is 4 minus 3, which is 1. And then I stop because I can't keep going, right? Now, always, if it's written response, show every single coordinate. We're running out of time, so I didn't show the last two. But always just show your work. Okay? Then we're flipping over. So this one wants to know which one gets me f of x is x. That ain't confusing, nothing is. So we're going to do this and see if we get x for which one. So I'm going to do this one. So I do f of x. And what is f of x? It's x. So now I'm going to get f of x. Because f of x is x. And then what is f of x? It's just x. That one work. This one, I'm going to do f of x. And what is f of x? Negative x. And then what do I have to do? I have to plug this in for the x and f of x. So what am I going to get? So I'm going to get negative x, just one in the middle step, which is x. You're plugging it into the x of f of x. You're plugging it into for here. Then here I have f of x equals f of 1 over x. And now I'm going to plug this into the x of 1 over x. So watch. I'm going to get 1 over x. Do I ever stack fractions? I'm going to go 1 divided by 1 over x, which is the same as 1 times x over 1, which actually equals so it's all of them. Okay, this one, I want f of g of negative 3. G of negative 3 is 3. So I get f of 3. And f of 3 is what? 0. So what did I just find? I found a coordinate at, what is it? Negative 3, 0. This is my input, that's my output. On the graph of what? F of g of x. Input's negative 3, output is 0. On the graph of f of g of x. So here it wants f times g. So I'm going to get f of 0 times g of 0. F of 0 is negative 1. G of 0 is 2. So I get, that's a multiplication dot, even though it looks like a plus sign, negative 2. And then this one, g of f of 4 is g of, what's f of 4? Negative 1. So it's g of negative 1, which is 3. So what did I find? 4, 3 is on the graph of g of f of x. Then this one, they want you to determine k. F of k equals 1. This is a grade 10 question, just so you know. This is, I need an x when y is what? When y is 1, I need the x. So I go like this. So what could my x's be? Whatever the heck that is. 1, 2, negative 2.8. And 2. Okay. So you guys can sketch these. We'll deal with that in a second. I want to go through some equation writing before you guys bolt, please. So let's look at this. How do I get the equations of these? We've talked about this. So this coordinate on a radical is awesome because it normally starts at 0, 0. It's now at negative 3, 2. So that gets me my horizontal and vertical translations, right? So it's at negative 3. So I'm going to get x plus 3. And then it's at 2. So I get a plus 2 at the back. Do we agree? And then I said if it's up and to the right, it hasn't reflected. What is this one? Up and to the right, so there's no reflections. We agree?
Yes.
Okay. The last thing I told you is normally the graph is like this, 4, 2, 9, 3. It's normally like this. We agree? So I told you guys, when I taught you this, that it's normally a 1 by 1 box. Correct? To the next point. What's this one? Oh, thanks, little. Okay. It's 1, 2, 3, 4 by 1. So what did we stretch by? Horizontally by 4. So what goes in here? Thank you. We brought back our brains. How could they give it to me though? Remember we said these ones were special? They could move it out. How would it come out? A half. Remember, you can take the square root of it and move it out. If it was a vertical stretch, you could square it and move it in. I can take that quarter and move it out by rooting it, right? Okay, I want to get through these and I want to get through some rational ones, so let's get on the back. Okay, B, I have y equals, now I'm at 6 and negative 4. We agree? I should be at 1 and, or 0, 0. I'm not. I'm at 6 and negative 4. So I'm going to get x minus 6, to move 6 to the right, minus 4. Is it up and to the right?
No.
No, it's up and to the left. So which axis am I reflecting on? The y-axis. Because if it was to the right, now it's to the left, it's the y-axis. And what does the y-axis get me a negative in front of? Then I'm normally a 1 by 1 box. Now I'm a 1 by 4. So this is a what stretch? Vertical. So it could sit in front, or I could take it under the radical. How do I get it back under the radical? I square root it to get it out. So how do I get it back in? Square it. So or y equals the square root of negative 16 x minus 6. So what is the other stretch? Horizontal stretch by factor of 1 over 16, which makes sense because if I did a 1 by 1 box here, I only went up 1, I would go over a 16. It's a heck of a lot harder to figure out though, so I always find the easy one and then just move it in or move it up. Okay, you guys have to be able to do this. Invariant points algebraically. I said this. I said you have to. What do you do when it's invariant points algebraically? Y equals 1 and y equals 0. And one of them will probably factor, and one of them you're going to have to use quadratic formula. We discussed this. So you're going to get 1 equals 4 minus x squared. Move the 4 over. Negative 3 equals negative x squared. And then I get 3 equals x squared. And then when I take the square root, what do I have to remember to do?
Plus minus.
Plus minus. So what are my coordinates? Because that's just an answer for x. X equals plus minus root 3. That's not an invariant point. Plus root 3 and 1 and minus root 3 and 1. This one was nice because it didn't have an x value. If it has an x, you have to move everything to one side, set it equal to 0, and quadratic formula it. Remember?
Yes.
Now this one is 0, so I get 0 equals 4 minus x squared. Move my 4 over. Divide by negative 1, I get x squared equals 4, square root, plus or minus, x equals plus or minus 2. So I get 2, 0, and negative 2, 0. What if I use the quadratic formula and I get a negative under the square root symbol? There is no invariant point there. Which could be that the graph is concave down and it doesn't actually get to 1, right? So do not write, sorry, I don't know how to do this one. Do not find it on your calculator and give me 4 points. You're getting 0 marks. That's not algebraically at all. But I found them, Mrs. Lepp. Don't care. Like I care, but I don't. Okay. Okay, what if I give you this? I'm going to show you the quickest, fastest way to come up with any type of rational equation. So we can go y equals a. We always have to find that a, correct? Now, on the bottom goes my vertical asymptote. What's my vertical asymptote? X equals -1, so what am I going to get down here? X plus 1. And at the back, horizontal, which is plus
Plus 1. Plus 2.
plus 2. And I would be done if there was no point of discontinuity. This one has a point of discontinuity at 5. It should be a heck about 5 and 1, it looks like. Okay, so it's at 5. We agree? So instead of doing it the other way, what could we do? We know that if we have a point of discontinuity, the factors do what? So cool, let's write them on here. X minus 5, X minus 5. Make it join this. Can it not? Instead of doing the x-intercept and all that stuff, can we not just add it to that one, the transformed one? Absolutely. And then we could use 2, 0, let's say, and find A. These should not be hard equations to do, right? Should not be difficult if you know your rules. So you're going to go y is 0, left, grab a minute. 0 equals A 2 minus 5 over 2 plus 1, 2 minus 5. Do we really need to keep these in here? Do we need to keep these when we solve for A? No, we don't even need to include these when we solve for A, because what are they going to always do? Cancel. You have one on the top and one on the bottom. You have to put them back when you're given the equation. Then plus 2. Subtract my 2 over, I get -2 equals A over 3. Multiply by 3, and what's my A? -6. So my equation is y equals -6, x minus 5, over x plus 1, x minus 5 plus 2. Now what if they wanted it as a full fraction?
Uncommon.
You would have to make a common denominator. Right? You have to multiply this one by x plus 1, x minus 5, and distribute it in the top. But more often than not, they're leaving it like this now because that's transformed. And that's what we do. We're doing transformations of graphs. Not can I make a full fraction like I do for calculus. It's totally different rule using those.
So if it doesn't say exactly
If it doesn't say, you can leave it like that. Absolutely. And what about this one? I want to go over this one quickly. What if I give you two vertical asymptotes? You're going to get y equals A. Vertical asymptotes. This one's at -4, so I get x plus 4. This one's at 3, so I get x minus 3. They put an x at the top. Why is there an x at the top? What is my horizontal asymptote at? 0, and I know the rule is that the numerator has to be a smaller degree than the denominator, right? So this one's going to be x, and then this can be x squared, so it's 1 degree less. And then I just use a point and solve. And if you didn't know it, look at, they gave it to you anyways. Use a point and solve. Here's the point. So I get -2 equals A times -6 over -6 plus 4, -6 minus 3. -2 equals -6A over -2 times -9. Okay, negatives. -2 equals -6A over 18. You multiply 18 up if you want.
Are we sure there's a horizontal asymptote? That graph in the the line, the S in the middle, like looks like
It's how it ends. It's not how it crosses through in the middle. Big old calculus conundrum. So your asymptotes are end behavior. It doesn't have to go through the middle, it can pass through. This one does go through, it's at 0, 0. But it causes the end behavior to occur.
Oh,
Yeah.
18. No, but then you had to.
So an asymptote doesn't stop things from